Think Squad is made possible by AT&T, investing to bring wired and wireless internet to America's communities, because the future has always been our business. AT&T, your world, delivered. The American Honda Foundation, a proud sponsor of Detroit Public Television's Think Squad project and committed since 1984 to improving science and math education for youth across America. To learn more, go to www.foundation.honda.com. And from contributions to your PBS station from viewers like you. Thanks.
People say science can be a real drag. I say that's just because they don't have the right support. I'm Alexis. I'm the leader of the Think Squad. We help kids solve problems, all kinds of problems. I've got a good team. There's Christopher. He's my right-hand man. He doesn't say much, but he misses even less. If there's something worth knowing, it ends up on his clipboard. Then there's Cameron. She's a reporter for the school news. During her interviews, she always finds a way to slip in a few extra questions for me. And when it's time to test that hypothesis, that's where Gary comes in. If he's not building something, he's probably taking it apart. Luckily, Sam's around to make sure he doesn't blow his goggles off. But don't get to thinking we're here to do your homework for you. No way. We provide the method. You provide the conclusions. We'll even fire up the think tank to help you sort everything out. What's the think tank? Don't worry. You'll find out. Just call the Think Squad. There's no problem we can help you solve.
Hello? I'm not sure I'm in the right place.
Well, I guess that depends, doesn't it? What exactly are you looking for?
I guess you could say I'm looking for some help.
What kind of help?
It's just, well, I've got a pretty big problem.
That's good, because problems are our specialty.
They are.
Welcome to the Think Squad. There's no problem we can't help you solve.
Yeah, I saw your ad.
Great idea on the advertising. So, what's your problem?
Well, see this rock?
Yeah.
That's the problem. It's not just any rock.
Looks just like any other rock to me. So, what's so special about it?
How do I put this? It, crashed through the roof of my house.
Excuse me?
It crashed into my bedroom.
That would suggest that it was some type of meteorite.
Right, and no one believes me. I brought it in class and everyone thinks I just made it up.
Sounds like a problem.
That's why I'm here.
No, that's why we're here. You've come to the right place. The Think Squad will definitely take your case.
So what is it?
Our client thinks it's a meteorite.
Well, so you're trying to tell me that this thing right here, you see this thing, is from outer space?
That's exactly what we need to figure out.
Maybe when your pencil gets dull, you'll want to give this a try.
Do you even know how that thing works?
You kidding? I can get like up to 20 times magnification on this baby.
Yeah. You might want to turn it on first.
I knew that. So you really think that thing is an honest to goodness meteorite?
I mean, that's what she says. Haven't you ever heard the expression, the customer is always right?
Customer? Last time I checked, we weren't getting paid for this gig. Though, if that is what she says it is, it's gonna be worth quite a pretty penny.
Slow down. We're here to help her. How'd you like it if nobody believed you?
Yeah, that was a little thing I like to call the 7th grade.
I'm just saying. We don't know what it is, and until we do a little investigation, we won't be able to help her.
I say we just cart this baby down to the lab and cut her open for a little alien autopsy.
Nobody is cutting anything open. Christina brought this to us. She's trusting us to tell her what it is. You guys know the drill. Simple scientific method. We establish the problem.
The sky is falling. Done.
We observe the data in the field.
Now you're talking.
And then we formulate a hypothesis based on what we find out.
Think tank, anybody?
And we test it.
Why is that the last step again?
But first, we need to do a little reporting. Sounds like I've got a new lead for this week's Y News.
And I've got just the person for you to interview.
Hello everyone, I'm Roland.
And I'm Marjani. Your Y News update starts right now.
Meteorites, just a disaster movie plot or something we should really be watching the skies for?
Meteorites are very much real and more common than you might think. No, they're not always the size of Texas and intend on ending life as we know it. But in fact, meteorites come in all shapes and sizes, with over 31,000 documented meteorite finds in history.
So what is a meteorite? Technically speaking, it's any natural object that hits the Earth's surface and survives. Of course, satellites and other junk that we put up there doesn't count.
If a meteorite is found, it fits into one of the two categories, a fall or a find. So what's the difference? Well, we sent Y News reporter Cameron into the field to find that answer.
Thanks, guys. So what exactly is a meteorite? And if you found one, how would you know where it came from? Well, I'm at the Cranbrook Institute of Science to meet with an expert who knows all about it.
Cameron.
Hi, John. John Zawiski is a geologist paleontologist at the Cranbrook Institute of Science. After growing up on the east side of Detroit, he got degrees from Wayne State University and Ohio State University before he became Cranbrook's resident expert on meteorites.
You know, oftentimes people ask if this is a meteorite.
Looks like one.
It does have sort of an odd appearance to it, but it is spherical. It's actually a chemical concretion, and meteorites typically are not spherical. They may be rounded in places, but never spherical.
Oh, okay.
Well, down this way, we have over 1,000 crystals just in these cases right here. Wow. Well, come right on in.
So what exactly is it that you do here?
Well, I'm a geologist and paleontologist here at the Institute, so part of my job involves working on exhibits and developing programs, but I also go out in the field, do field research, actually all over the world. I've worked in Antarctica, South America, Australia, all over the Southwest U.S., and of course right here in Michigan. And I also curate the rock and mineral collection here at the Institute as well.
So what exactly does it have to do with meteorites?
Well, in a way, meteorites are in the rock collection. They're just rocks from outer space. And I do happen to have a rather famous meteorite right here. This was actually what we call a find. It was part of a huge field of iron meteorites that was found in the middle of the 16th century by Spanish explorers in Argentina. Wow. And native people even earlier than that. When we actually see them fall, then we can record the exact date and time of their fall. So we have finds and falls. This one, as you can see, is heavily rusted. It's a type of meteorite we call an iron meteorite. And part of our project here will be to try to refurbish it.
So have there ever been any documented cases of something like this actually hitting someone?
This one weighs about 200 pounds, so that would be nasty. But actually, it's extremely rare. And there's one really well-documented case back in 1954. A meteorite went right through a roof and hit a woman who was on the couch right in the thigh, Ann Hodges.
Wow.
So it is rare, and certainly not something we should worry about.
But they do hit houses from time to time.
Oh, absolutely. And right here in Michigan, one went through a garage roof just outside of Ann Arbor. I actually have a cast of it back here if you'd like to see.
Okay.
Come on, I have some meteorites back here. Okay, now right in this drawer, yeah, this is a cast of the one that went through the garage right in Ann Arbor. This went right through the roof and into a car.
So if you find something that might be a meteorite, how do you know if it is or if it isn't?
Good question. There are really three basic kinds of meteorites, and the one that really sticks out as different from Earth rocks are the irons. So this thing weighs 3.5 pounds.
Wow.
It's about 90 to 85% iron, and is really strongly attracted to a magnet. But inside this type of meteorite, we can actually see when we cut and etch them, the crystals that make them up, iron nickel crystals. Wow. So these formed from hot fluids deep inside asteroids, and they're really core fragments, very much like what we find probably in the Earth's inner core itself.
Okay.
Now the other type are stony. These are much more like Earth rocks, a little trickier. Okay. They have a density that's, well, they're still pretty close to normal Earth rocks. They have a little thin crust on the outside called a fusion crust. And then on the interior, there are little BB-sized particles. They're called chondrules. So another name for this type of stony meteorite is a chondrite.
Okay.
And these are the most primitive materials of the solar system. These are very ancient, some of the very first solid matter in the history of the solar system. Now the third variety, they're called Stony Irons. So they do have crystals, the type we find in Earth rock, silicate minerals, and they're embedded in iron. So we think these represent a transition between the mantle and core of the asteroid. These are much, much rarer, however.
So no matter if a rock came from, say, your backyard or outer space, there are ways to tell where it came from.
Well, absolutely. I mean, first of all, things like the fusion crust on the outside, the attraction of a magnet. Beyond that, there are a whole host of really neat tests you can do to determine whether what you've got is really a meteorite.
Well, you heard it here on Y News. Meteorites are something you most likely don't need to worry about. But if you still think they're pretty cool, you never know. You could become a geologist, paleontologist, and work with them every day. For Y News, this is Cameron.
Have you ever been wrongly accused? Do you have a hard time convincing people you're telling the truth?
But I wasn't cheating.
Do you need someone to prove your case?
You better think squad.
When everyone had accused me of cheating, the Think Squad used handprint analysis to prove I did not copy that paper, and they cleared my name. Thanks, Think Squad.
There's no problem we can't solve. Contact us with Think Squad. Hi, I got your message.
Welcome back. I've got some news for you.
Good news?
Maybe. The good news is that we now know what a meteorite is and what it isn't. And based on our findings, I think it's time that you make your hypothesis
Hypothesis?
about your rock. Is it a meteorite or isn't it?
So how do we do that?
I think it's time that you met the think tank.
Where are we going?
Just wait.
Isn't this just a janitor's closet?
Most of the time, yes. Sometimes it's a little more than that.
This is the think tank.
This is the think tank. You think you have a meteorite? This is where you get the information to make a hypothesis about whether you do or you don't.
How?
Load Meteorite report.
Meteorites are natural objects from outer space that have survived an impact with the Earth. While in space, it is called a meteoroid. When it enters the atmosphere, impact pressure causes the body to heat up and emit light, thus forming a fireball, also known as a meteor or shooting star.
Think tank, pause report. Do you think you have that? Continue report.
Due to the intense heat caused by a meteoroid entering our atmosphere, most simply disintegrate before they reach the ground. Still, scientists estimate that about 500 meteorites every year do reach the Earth's surface in one piece. These surviving pieces of extraterrestrial rock can be as small as a marble or as big as a basketball. Only a handful of those are usually found and identified. A flash or burst of light in the sky is not uncommon as the meteorite enters the atmosphere, in addition to a rumbling sound caused by the sonic boom and shock waves caused by the speed of the object. Whistling or hissing sounds have also been heard, and people who have found meteorites report them to be warm to the touch.
Pause report. So, what do you think?
Sounds like this could be a meteorite. And it sounds like it's happened before.
But not often.
And I didn't hear anything or see any flashes of light just before it happened.
Sounds like it could go either way. So, based on what you know now, what would your next question be?
I guess I want to know what found meteorites usually look like. What are they made out of?
Go ahead.
Think tank? What do meteorites look like? What are they made out of?
The most common meteors are chondrites and identified by small balls of stony material called chondrules that are about 1 millimeter across. You need to slice a meteor to see them. Meteorites are also heavy, made mostly from extraterrestrial iron, and most are shiny and metallic in appearance. Almost all easily stick to a magnet, yet they are not magnetic. They also have what is known as a fusion crust, the melted exterior of the meteor that forms as it passes through the atmosphere. Not all look the same. Usually they are dull black, but some fresh ones have crusts that look like shiny black plastic, and others are light yellow-brown.
Think tank, pause.
So?
I don't know. I mean, it did crash through the roof of my house, so it had to have fallen from the sky, and fallen pretty fast. But it sounds like we'd have to know what this rock was made out of. Think tank, how do we test a meteorite?
When observation fails to determine the authenticity of a suspected meteorite, any number of scientific tests can be run to determine the rock's components, such as a scratch test or acid test.
Think tank, pause. All right, what's your hypothesis?
I guess I just have to believe it's a meteorite right now for it to have fallen that fast out of the sky. But it sounds like we need to do those tests to know for sure. Do you know anyone who can do those?
I just might.
So, what's this about a rock?
Finally. So when do we get to cut it open? Or do you have something that instantly vaporizes it and tests the otherworldly material left behind?
Wouldn't that be cool? But no, it's actually a lot more simple than that.
So what are we gonna do?
Well, in the case of meteorites, simple field tests like a scratch test or an acid test first can be used to determine whether this meteorite is more of a meteor wrong.
Cute.
Thanks.
So how do you do a scratch test? Is it like the meteorite has an itch?
Kind of. And actually, a fingernail can be used as one of the first things to perform a scratch test.
So what does a scratch test tell us about the rock?
Well, basically, it tells us where the rock ranks on what's known as Mohs hardness scale.
Mo. Who's Mo? Does he work here?
Not exactly. It's not Mo. It's Mohs. Friedrich Mohs. He was a German mineralogist in the early 19th century. He established a way to classify and rank rocks and minerals based on how easily they were scratched by other objects of varying hardness.
Like what?
Let's start out over here. First, let's try a fingernail test. Go ahead and see if you can scratch it with that. How's that? Does it scratch?
Pretty much no.
All right, well, let's move on to something else. How about this penny? What does that do?
Well, let's see if we can't scratch it with the penny.
Get anything?
Scratch the penny, but it didn't scratch.
Okay, now let's move on to that glass.
Left a bit of a scratch there. Doesn't look like it scratched, though.
Oh, now let's try that nail.
It's scratched. So where would you find this on the Mohs hardness scale?
Well, this will rank as a 6 on Mohs hardness scale. See, it scratches glass and gets scratched by that iron nail.
Okay, so I get being able to figure out how hard or soft something is by how easily it scratches other stuff. Like, if it scratches real easy, it certainly can't be metal, right?
It depends on the type of metal, but I think you got it.
But what about the acid? What's that gonna tell us?
Well, the acid tells us whether or not this oxidizes. It basically reveals the true mineral properties.
All right. Let's oxidize this baby.
All right, now we're gonna start this acid test, this limestone here. Now grab this acid, and I'll pour it on the limestone. Let's see what happens.
Ooh,
Exactly.
that's cool.
Oxidation. But now let's see what happens with this meteorite. Go ahead and try that out.
Let's remove our specimen. Nothing happened. So it's meteorite then. Cool.
Hold on, Galileo. We're not done yet.
We're not?
In the case of meteorites, you always want to be 100% sure you know exactly what you have. And there's still a lot that this could be that's not a meteorite.
So what now then?
But now we have to weigh the specific gravity.
So how do you weigh gravity?
Specific gravity gives you a hint of what a rock is made of without cutting anything open by telling you the weight of the elements and how close them are packed together. All you need to do, especially for a heavy object, is find the weight of the rock in grams.
358.9 grams. Then what?
Now find its volume, or the amount of water it displaces in cubic centimeters.
Because the weight of 1 cubic centimeter of water equals a gram?
Exactly. All right, so go ahead and drop that in there.
You bet.
See what you get.
Drop our mystery rock into the fluid.
All right, so what's the reading on here?
About 100 cubic centimeters.
Okay, now divide the weight by volume.
3.589 grams per cubic centimeter.
Well, meteorites are usually 7 to 8 grams per cubic centimeter. Looks like you got some bad news to deliver.
But I don't get it. If this rock didn't come from outer space, where in the world could something like this come from?
Are you sure? I mean, 100%?
I'm sorry to say, miss, but field tests proved it. That rock is just a plain old piece of nothing special Earth.
So everybody was right.
I wouldn't say that piece of Earth was nothing special. I mean, it did fall from the sky. And that's a great story.
If we only knew what the story was.
But it doesn't make any sense. If it didn't come from outer space, what could a rock be doing so high in the sky? Think tank, I need a map, please. Detroit, Michigan, East Hilldale Street. That's my neighborhood. Think tank, zoom back out. Stop. That's the airport.
And?
And for a normal chunk of rock to have fallen fast enough to crash in my roof, it had to get pretty high. The only thing that gets that high is a plane. A plane that probably had a chunk of rock stuck in its landing gear. This isn't a meteorite. It's just a huge chunk of runway.
Scientifically speaking, I call that a very sound conclusion. Congratulations.
Congratulations for what?
Now you're a member of the Think Squad.
Think Squad is made possible by AT&T, investing to bring wired and wireless internet to America's communities, because the future has always been our business. AT&T, your world, delivered. The American Honda Foundation, a proud sponsor of Detroit Public Television's Think Squad project and committed since 1984 to improving science and math education for youth across America. To learn more, go to www.foundation.honda.com. And from contributions to your PBS station from viewers like you. Thanks.